Hi, welcome back to fraction multiplication. This is part 3. I am now using a gizmo, the multiplying fractions gizmo, to make a few points that I haven't quite addressed yet about the topic. So I'm going to model the, the multiplication of 2/3. So I'm going to make my 2/3 there. And before I go further, I'm going to click Show Fraction Model so that we can see that the wholes are divided into their fractional amounts. Now, if I multiply 2/3 by 3/4, I get this. And very much like my garden drawings in part 2, you can see how there's an overlap of the two fractions. So where the red and the blue overlap to make purple, that is the selected box that's going to end up being our numerator. Okay? And that's how this works. So again, just like those diagrams that I was drawing, perhaps even better because I'm not drawing them this time, we can see the relationship between uh, the area model and the uh, algorithm that's pictured up top here. Now, I don't have a pen function in this environment, which may or may not be a good thing, but if we take a look at the whole, the whole is 3 units by 4 units, making 12 units, and we can see that reflected in the denominators of the factors and eventually in the denominator of the product. The numerators, 2 times 3, that's going to give us 6. We can see that in the purple box, the smaller purple box, which is a visual of the numerator of the product, 2 by 3, and that's going to be 6. And we'll just show the calculation. There it is. So a student looking at this model will be able to see the numbers in the algorithm reflected in the model, and it will make more sense. But I wanted to make a couple of points, and here's one. I'm going to turn this off. I'm going to change the denominators to eighths. Okay. Now, if I want to multiply a small fraction by another small fraction, um, I'm going to end up with a fraction that is much smaller than either. Okay, so 1/8 times 1/8. If I can get this to move, there we go. 1/8 times 1/8 is going to give us that tiny little purple square in there. That's not a lot. That's 1/64. And this is a good image to show students to help them overcome that misconception that multiplication always makes things bigger. And then to talk about why. Because we're not scaling up, we're scaling down. Okay? So long as we're multiplying something by a value of less than 1, we're scaling down and making it smaller. Um, the closer my fractions are to 1, as in this case I move it up to 7/8 times 7/8, the closer these fractions get to 1, the closer my product will also get to 1. Still smaller than each of the factors because again I'm scaling down. I'm not doubling or increasing by a factor of greater than 1. So I'm still scaling down, but we can see that I'm closer to 1 now than I was before. So let's talk about fractions greater than 1. So let's maybe change this to halves, and maybe bring that right back because it's looking kind of silly. Bring those right down, and change this to thirds. No, I don't like that. I'm going to go with fourths over here. Okay, so if I model 2/3 times 3/4 again, I can see that I've taken my 2/3 in red. I've selected 3/4 of them, and I end up with something that is smaller than either factor. But if I move it up, if I say, okay, I'm going to keep 2/3, but this time I'm going to multiply by 5/4. Now we can see the impact of multiplying by something greater than 1. Okay? If I multiply by a value of 1, I get the same thing. And we know that from our whole number multiplication. If I take any value, multiply it by 1, I end up with the same value. 2/3 times 4/4 is going to give me a value equal to 2/3. But the minute I increase that second factor to something greater than 1, something really interesting happens. I am now scaling up. Okay? So 2/3, and I am taking of more than one amount of 2/3. I'm taking 5/4. So that's a whole set of 2/3 plus another quarter of that 2/3, and that gives me 5/6. 5/6 is greater than the 2/3 that I started with. So it is scaling it up. Let's try even more. I'm going to multiply by 6/4 or 1.5. Now I'm really scaling up because I started with 2/3. I'm taking that full 2/3 plus 2/4 of another 2/3, and that gives me a value of 1 essentially, because these 4/12 in the second block I can rearrange into the first block and make a whole. So with a representation like this, you're able to show students that as you multiply by numbers greater than 1, you are actually scaling up from that first factor. But that when you are multiplying by values less than 1, you are scaling down. And that can help them overcome the misconception that that multiplication always makes things bigger.